as we just saw, if prices increase, then the change in M is going to be positive. If the prices decrease, I guess I need an N there, then the change in M is negative, like the adjustment of income to make the old bundle just affordable or to hold purchasing power constant, we'd have to like take away income if the prices of one of the goods fell. So the optimal bundle, like the original optimal bundle, is just affordable. So when I say the optimal bundle, I'm kind of talking about that, X1 star, X2 star. But it's not usually optimal. So we're usually going to change. I mean, we're going to see a couple of cases where we might not change our decision about how much to buy of each good. But we're usually going to think that we're going to change our optimal bundle when we have a price change and an income change. And so if we're going back to that graphical representation we saw, the sub-effect, I'll write it over here, is that movement or the distance from A to C. That's that sub-effect. Kind of we looked at the graphical representation of the income and substitution effects a couple videos ago. So to calculate, we've seen the change in income up here, so to actually calculate the sub-effect, we're going to use the demand function to calculate the optimal bundles with the new prices and the new income and compare that to the old price and the old income. Let's call it P1 prime for the new prices and M prime for that new kind of compensated income where we're adjusting income to keep purchasing power constant. And the original one, which is just, P1 and M. Now this change could be large or small, and that's going to depend on preferences. And by preferences I mean the indifference curves as well, right? Preferences are represented by these indifference curves. And so different shapes of indifference curves are going to lead to different sizes of this substitution effect. So the change could be large or small. So again, this kind of, whether it's large or small, hoping this shows up at the bottom of the screen, depends on indifference curves, which of course depend on preferences. So let's take a look at an example of this effect, kind of going through those steps that we just talked about, or kind of going through that, or applying that theory, I should say, that we just kind of learned about. So let's say the demand function for x1 is the following. x1 equals 10 plus m over 10 times p1. So we learned kind of how to derive this before in past videos. So that's like the optimization. We could use the Lagrangian, we could use unconstrained optimization, we could use the MRS condition. One of those ways with the budget constraint, we can kind of derive the demand function. Let's imagine originally income is 120 and the price of good one is $3. So that would mean x1 star, the original optimal bundle, is 10, or the optimal amount of good one, I should say, over 120 over 3 times 10. Well, that equals x1 star equals 14. 120 over 30 is 4, 10 plus 4 is 14. Now let's say if price decreased, let's say, do a little better notation than that. If the price of good one decreased to $2, well, we could figure out the optimal bundle now. I'm going to put 2 stars on it. 10 plus 122 times 10. Now it's 10 plus 120 over 20 is 6, so 10 plus 6 equals, so the new optimal bundle is 16. So now the total change from this change in price is 2. That's that total change from like A to B on the graph. And then that's what we want to decompose into the income and substitution effect. So the total change in good one is 2. And we want to decompose this into those income and substitution effects. So the first thing we need to do, and we just kind of saw an example of this not too long ago, is figure out like the new income we need to be to just afford this old amount of good one. So let's quickly erase this board, start there, and then calculate the substitution effect. Calculate the sub effect. First calculate an A, the change in income. And so we kind of figured out this before, so the change in M equals x1 times the change in the price of the good. Well, in the example we just saw, the amount of x1 was 14, because that's how much they are purchasing originally when we plugged the original price and income into the demand curve. And the change of prices, this example, it was $1, right? It went down from $3 to $2, so that's minus 1. So the change in income necessary is to reduce their income by $14. And this kind of makes sense. If the price is going down and we want to make that old bundle just affordable, so we want to keep purchasing power constant, then their income needs to go down. All right, so now income needs to go down $14, which means kind of M prime, as we've been saying, is M minus this change in income, which is M minus 14, which is 106. All right, so now M prime is 106. P1 prime is $2 because the new price is $2. And we can plug that into the demand curve. Remember, x1 equals, or the demand function, whatever that may be. In this example, it's 10 plus m over 10 p1. And now it's going to be p1 prime. So we can plug that in, 10 plus 106 over 10 times 2. And that's going to be equal to 15.3. And so the sub effect is going from 14 to 15.3, so the sub effect is 1.3. So holding purchasing power constant, but just changing the relative prices of this good has caused us to increase our consumption of that by 1.3. So that's how we theoretically think about it, and this is how we calculate it if we actually had numbers.